introduction. So this is where we've stopped last meeting. Right here, exercise number 5. I mean yesterday, not last meeting. So any questions so far regarding with your exercise number 5? Hello? Buhay pa ba kayo? Anyway, so I guess all of you were eating your breakfast. Okay, so if you guys are not there, then just watch this recorded video. Okay. All right, so let's move on to the exercise number 6. So again, just ask me a question anytime if you have a question. Windows Forms. So let's try this exercise number 6. All right, so it says here a bank offers a car loan at the rate of 15% compounded monthly and write a program allowing the user to input for the loan amount of the car and period of years to pay. Compute and display the monthly payments to amortize the loan and determine the total amount at the end of the period. So we have this formula for the interest. So we have the compounded interest divided by 12. So you have to divide it by 12 because you're going to pay it monthly. Okay. So here's the monthly interest. Okay. And we have here the N or the count of years, wherein of course you have to multiply that 1 by 12. So if you're going to put here 1, okay, then it will be multiplied by 12, then it will give you 12 months in total. Okay. So if it's 2 years, of course, it will give you 24 months to pay. And here is the formula for the, I think this is the, A is the amortization. 1 plus interest. Okay, let me just check. What is this letter P right here? I think letter A is the amount to loan, and letter P is the computed value. So it's either the annuity or the total contribution. So let's see. Amortization. All right. So this letter P is your amortization amount, okay, which is this one, the annuity. And then the last one is the total amount that you have already paid on that month. So let's say you have already paid 3 months, so a total of 54,154. So basically, this is just your total contribution on that specific month. Okay, and this is your monthly payment or amortization that you need to pay every month. All right, so with that being said, so let's try this one and then let's analyze this on the Visual Studio itself. So before that, the things that we need is a text box, numeric up down, a list box, 1 button, and then 2 labels. Okay, so a text box, label. So we need 2 labels. What else? Numeric up down. And a button. Box. And what else? So that's on it. We'll just make this one bigger to size 15. And this one to size 30. And this one also to size 30. And the labels will be size 30 also. So if you guys have a question, so feel free to ask me anytime. So we have here amount to loan and then years to pay. Amount to loan. And years to pay. This button to size 30. Compute annuity. All right, and this is where we're going to put the code. Okay, so we have declared here 1, 2, 3, 4 variables as single. So again, if it's declared as single or double or decimal, meaning this can accept a decimal. Okay. And we have here term and then m as integer. So for term and m, so it will only accept whole numbers. And whatever is the value of our text box 1 will be passed on to our variable p. Okay, so text box 1 is the amount to loan. And this one is numeric up down. Let's change this one. Numeric up down. And this one is this box one. And this box one. Okay, so this is the months. Okay, so basically, you can only put a whole number right here. Okay, so this is the years to pay. So if it's 1, then it will be multiplied by 12. So a total of 1 year. Okay, 12 months. So if it's 2, then a total of 24 months. And here is a formula for the interest. So we have to divide this 1 by 12. Okay, so this one will be computed per month. Okay, so that's your interest per month. So actually, you have an interest of 15% a year. But since our calculation will be monthly, so you have to uh, divide this 1 by 12. So it's by month. And supposedly, we will add here a name wherein we have here month, annuity, and then total contribution. But we are not going to do that one anymore. Okay. Since we have already declared or included here the names or the titles, okay, for the month, annuity, and total contribution. So if you want to put it manually using the list box and then going here by the to the collection and typing everything right here, then you should remove this one because it will double the title or labels on that list box. And here's the computation for the monthly amortization. So we've just simply followed the formula. Okay. All right. So in here, oops. So in here we have A as your total, okay, which is this one P times int is the interest, okay, times, oops, where's this? Why do we have, okay, so let me just fix this one. I think we need more brackets. P times 1 plus int interest. Okay, let me just include another bracket here. us to be able to see it clearly. Okay, so P, oops, P right here is the A, okay? And then 1 right here is the 1 right here. Why do we have double interest? Okay, let me just check this one. Interest raised term. 1 plus interest. Hmm. Okay, ang numbers ko, para di ma-type. Okay, so let me just check if the formula is correct or no. Since the int or the interest is doubled, so in here we have 200,000 for 1 year. So that's correct. However, we have B here as letter A, and then supposedly it should be 1 plus int raised to term, which is correct. Why do we have times int in here? Numerator, but we don't have the minus 1. What happened with the formula? 1 plus interest raised to term times, I see.
Baliktad ata sir yung formula.
Okay, why is it the opposite? Okay, let's see if these still have the same result. So P times 1 plus int raised to term minus 1, okay, and then divided by int times 1 plus interest raised to term. So 1, 2, 1, 2. Okay, let's see. So we have 200,000 and then 1 year. What happened? Unless the formula right here is really, the opposite. We just simply follow the formula. P is equal to. Anyway, so I guess there is a correction regarding with this one. So the one that is above should be this one, the interest times 1 plus interest raised to term. Okay, because when we have that kind of formation or format before, we've got the correct answer. But right now, we just simply follow this one. So yeah, we've got a different answer. So let's bring it back to the old one. Oops, no, that's wrong. Times in raised term interest 1 plus int raised to term minus 1. Alright, 3 times interest times 1 plus interest raised to term. Plus interest. 200,000. Oops, why still incorrect? Okay, let's go back with the original solution. P times int times 1 plus int is term 1 plus int raised to term minus 1. What's wrong?
Wala pang input ng interest, sir.
Saan?
Pag nag-input po dun sa interface natin, sir.
We have. There you go, 1. Oops, maybe I missed. Wala naman, dalawa lang input natin. We only have two inputs, the amount to loan and then the years to pay. Because the interest is already computed as compounded interest divided by 12, okay, which is this one, int. So int is equal to 0.15, 15% interest divided by 12. Anyway, so copy, paste, I don't know what's wrong with my old solution. Let's try if we get the same answer. Right, there you go. So I don't know what is my mistake on my solution before, but this is now the correct solution, okay, regarding with this result. So just interchange your numerator to your denominator. Just interchange those two and you will get the same answer. So I guess I should change this one. So maybe there is a mistake regarding with this one. All right, so yeah, there you go. That's it for this one, the computation regarding with exercise number 6. Okay. So I hope you guys were able to learn something regarding with this one. So in here, the main lesson is, so it is completely on how you pass your variables or your formulas, okay, on to the left side component or left side variable, okay. So again, our VB rates it from right to left. So from top to bottom, but it reads first from right to left, right? So it will process in this one first, and then it will be passed on to our amort, okay, and then it will be displayed on our list box one that items, okay, which is this one. And then for the total amount, so of course you will only get all of your amortization or the previous total amount, okay, and then it will be added as a new total amount. All right. So yeah, those are the key points for this example, okay, those formulas. Anyway, so yeah, that's it for exercise number 6. So let's move on to the next, well, this is an example. Well, this one should be your seat break, okay, for this coming finals. We are in a face-to-face method. And since we don't have that much time, okay, so, and you guys are also having a problem in, doing the laboratory. So I'll not give this one to you guys anymore as your seat break. But instead, we will answer this one right now, okay? So that you know how to do this one if you're interested to, have this kind of program where degrees will be converted to sine and then tangent. All right, so let me just save this one and then let's create a new one. Form app development framework. So seat break. Degrees conversion. So in here, we need a button and then a list box only. Button and a list box. Okay, and we'll put here the labels already. So number, is it number? Degree. Degree, tab, and then sine, and then another tab, and then tangent. Okay, let me just make this one bigger into size 30. Okay, just change this one into compute. And this is the one that you're going to program. So we'll declare two variable or three rather. So we have num, sine, and tangent, okay, as single. And then we have to solve for the value of num. So num initially we have here 0, okay, and then step by 10, so 0 to 80. So num is equal to 10, and then do. So I will use do while loop. So do while num is lesser than or equal to 8. Okay? And right here we have num is equal to num plus 10. So it's incrementing by 10. And we will display, right, so the computation of sine first. So sine is equal to num times sine times sine or sine only. Sine times num times, oops, is it sine? Okay, let me just go back with our notes. Sine, mat that sine. Ah, I remember. So mat that sine. That's why we're lacking something. Times the number that we have. And then we have to multiply this one by 180 since they are in radian, divided by mat that pi. So in that case, we now have a degree. I think we have a closing up in parentheses right here. Is it sine? As double. Ah, I see. Okay. So we have to declare this one as double since that single is not enough or sufficient. Is it? Why are we having an error? Not that sign, yes, double. Alright, so let me just check the format. Okay. I think there is something wrong with my sign. So we now only have 1 minute actually. So I think we'll not be able to finish this work. Anyway, we'll try. Ah, I see. So it's inside. Okay, it's inside of that close and open parenthesis. So we should have close and open parenthesis right here. Okay, and we will display that one on our list box. Oops, we forgot the tangent. So tan is equal to mat.tan number multiplied by 180 list box that items that add. So in here we have the num first and VB tab followed by the sign and VB tab again. And followed by the 10. This box 1 that items applied. VB tab sign. Why are we having an error? And VB tab. Ah, we forgot one end. And VB tab and tangent. All right. So let's see if this one is already working. Oop. The text is super big. Let me just make this 115. Oh, bakit sobrang laki pa